Most people believe a year is 365 days long, but if you want to understand how we actually survived long enough to build a civilization, you have to accept that a year is actually 366 days long. That probably sounds like a typo or a leap year joke, but it is a fundamental truth of the universe that our ancestors figured out while we were still wearing animal skins and sleeping in drafty caves. It is called a sidereal year. While the Earth takes 365 days to orbit the Sun from our perspective on the ground, it actually completes 366 rotations relative to the distant stars. That one extra silent rotation is the ghost in the machine of our planet's movement, and the fact that humans noticed it at all is the single most important moment in our history. It was the moment we stopped being just another animal reacting to the world and started being the species that predicts it. You probably know that feeling when you wake up at 3 a.m. and reach for your phone to check the time. You see the glowing numbers, feel a brief moment of relief or panic depending on your alarm, and go back to sleep. We are a species obsessed with the grid. We live by minutes, seconds, and calendar alerts. But imagine for a second that your phone is gone. Your watch is gone. Every clock on every wall in every city has vanished. You are standing in a field in total darkness. You have no idea if winter is 3 weeks away or 3 months away. You don't know when the deer will migrate, when the salmon will run, or when the frost will kill every seed you've managed to gather. In that world, the sky isn't just something pretty to look at during a romantic walk. The sky is the only screen that matters. It is a giant, glowing, slow-motion clock face bolted to your ceiling, and if you can't read it, you die. That is how astronomy was actually invented. It wasn't born from a desire to explore the cosmos or find aliens. It was born from the desperate, grinding necessity of not starving to death. You might think that because these ancient people didn't have telescopes, they were just guessing, but the reality is that their data was often more precise than what you'll find on a modern weather app. They weren't just stargazing, they were performing the world's first long-term data entry project. Around 30,000 years ago, somewhere in what is now the Democratic Republic of the Congo, a human being picked up a baboon's leg bone and a sharp piece of quartz. This is the Ishango bone. If you look at it, you'll see 3 columns of notches. For decades, researchers thought these were just tally marks, maybe someone keeping track of how many goats they traded. But then an American researcher named Alexander Mars Hack put that bone under a microscope in the 1970s. He noticed something strange. The notches weren't just random scratches. They were grouped in a way that perfectly matched the phases of the moon over a 6-month period. Think about that. 25,000 years before the invention of writing, someone was already outsourcing their memory to a piece of bone. They were tracking a cycle that took 29.5 days to complete, noticing the patterns, and recording them. That baboon bone is the ancestor of your Excel spreadsheet and your Google Calendar. It was the first time a human being said, "The universe has a rhythm, and I am going to write it down so I can beat it." Of course, knowing the moon's phases is great for counting days, but it doesn't actually tell you when to plant your corn. Actually, wait, that's not true at all, because the moon is a terrible way to run a farm. If you try to run your life strictly by a lunar calendar, you'll find that your months quickly drift away from the actual seasons. Every year, a lunar calendar falls about 11 days behind the solar year. Within a few decades, your summer months would be happening in the middle of a blizzard. To survive, humans had to find something more stable than the moon. They had to find a marker in the stars. Enter the Pleiades. You've probably seen them, a tiny, flickering cluster of stars that looks like a little smudge in the constellation Taurus. In almost every ancient culture on Earth, from the Maya in Mexico to the Aboriginal Australians to the ancient Greeks, there are stories about the Seven Sisters. The Greek poet Hesiod, writing around 700 BC in his book Works and Days, gave the most practical advice in history. When the Pleiades, daughters of Atlas, are rising, begin your harvest, and you're plowing when they are going to set. He wasn't being poetic. He was giving a user manual. When those stars appeared on the horizon just before sunrise, it was the literal start button for the agricultural year. If you missed that cue, your family didn't eat. Astronomy wasn't a hobby for the elite, it was the backbone of the economy. But you'd be wrong to assume that everyone used the stars just to stay in one place and farm. In fact, some of the most sophisticated astronomers in history used the sky to move across thousands of miles of open water with zero landmarks. If you've ever used a GPS to find a coffee shop 2 blocks away, the story of the Polynesian wayfinders will make you feel remarkably incompetent. These navigators managed to settle almost every island in the Pacific Ocean, a space covering a third of the Earth's surface, using nothing but their eyes and their memories. They developed something called a star compass. They didn't have a physical compass with a needle, they memorized the rising and setting points of hundreds of stars on the horizon. A navigator like Mau Pialug, who famously proved these ancient techniques, still worked in 1976 by sailing a traditional canoe from Hawaii to Tahiti, could look at the sky and know exactly where he was within a few miles. They used a technique called itak, where they would pick a reference island that was off to the side of their route. They couldn't see the island, but they knew which stars were supposed to be over it at any given time. As the stars moved, they saw the island moving beneath the stars in their mind's eye. It is a level of mental geometry that would make a modern astrophysicist sweat, and they did it all while being tossed around in a wooden boat in the middle of the largest ocean on the planet. Now, you might think that once we figured out how to farm and how to sail, we'd just settle down and stop obsessing over the sky. But actually, that's when we started getting really weird with it. As societies grew larger, they started building hard drives made of stone. If you go to Goseck, Germany, you'll find a series of concentric ditches and wooden palisades that are nearly 7,000 years old. It's a giant suncatcher. On the day of the winter solstice, someone standing in the center of the circle would see the sun rise and set through 2 specific gates in the wood. It was a massive, communal clock. But the most incredible Bronze Age gadget ever found isn't a giant circle of wood. It's a small bronze disc found in 1999 near Nibra, Germany. The Nibra sky disc, which dates to about 1600 BC, is a blue-green circle inlaid with gold leaf representing the sun, a crescent moon, and 32 stars, including the Pleiades. For years, archaeologists struggled to understand what it was. It wasn't just a decoration. Modern analysis suggests it was a sophisticated computational tool used to synchronize the lunar and solar years. If the crescent moon appeared next to the Pleiades at a certain time of year, the observers knew they had to add a leap month to their calendar to keep the seasons from drifting. This was a physical piece of software that allowed a Bronze Age chieftain to manage the time stream of his entire people. It represents a level of scientific thinking that we usually don't attribute to people who were still using bronze swords. It's easy to look at a bronze disc and feel a sense of connection to those people, but things took a very sharp, very cold turn when the Babylonians got involved. Around 3,000 years ago, in what is now Iraq, astronomy stopped being about stories and started being about spreadsheets. The Babylonians were the first true quant astronomers. They didn't care why the planets moved. They just wanted to know exactly where they would be. They recorded every eclipse, every planetary alignment, and every weird atmospheric event for centuries on clay tablets. This is where we find things like the Enuma Anu in Lil, a collection of 70 tablets containing 7,000 omens. But hidden inside the superstition was world-class math. They discovered the Saros cycle, a period of about 18 years and 11 days after which eclipses repeat. Think about the level of patience required for that. You have to have a civilization stable enough to keep records for hundreds of years just to notice that the pattern repeats. A Babylonian astronomer named Nabur-Imanu, working around 500 BC, calculated the length of the year with an error of only a few minutes. They were doing this with nothing but a reed stylus and a lump of wet clay. They invented the zodiac not for horoscopes, but as a coordinate system, a way to map the sky into 12 30-degree segments so they could track the wandering stars, or what we call planets, with mathematical precision. However, despite all that math, the Babylonians still thought the Earth was a flat disk. You'd think it would take a telescope or a spaceship to realize we are living on a giant ball, but actually, all it took was a librarian with a stick and a very long walk. In the 3rd century BC, Eratosthenes was the head of the Library of Alexandria in Egypt. He heard a traveler's story about a well in the city of Syene where, at noon on the summer solstice, the sun shone directly down to the bottom, casting no shadow. Eratosthenes noticed that in Alexandria, at the exact same moment, a vertical stick did cast a shadow. If the earth were flat, both sticks would have the same shadow or no shadow at all. Because the shadows were different, the surface had to be curved. By measuring the angle of the shadow and knowing the distance between the two cities, which he reportedly hired bemadists, or professional pacers, to measure by walking, he calculated the circumference of the earth. He got within a few percentage points of the actual number. He measured the entire planet without ever leaving his home province, using nothing but the sun and a bit of basic geometry. It remains one of the most elegant mic drops in the history of science. This brings us to a moment of total contradiction in the human story. You would assume that as we got better at math, we would immediately realize that the Earth goes around the sun. But the opposite happened. The more precise our observations became, the more we doubled down on the idea that we were the center of everything. Claudius Ptolemy, working in the 2nd century A.D., created a model of the universe so complex and so mathematically perfect that it lasted for 1,400 years. To explain why planets sometimes look like they are moving backward in the sky, what we call retrograde motion, he invented epicycles. He imagined planets moving in little circles that were themselves moving along larger circles. It was a nightmare of geometry, but it worked. It predicted the positions of the stars so well that sailors and kings used it for over a millennium. It was a perfect example of being functionally right while being fundamentally wrong. It reminds us that just because a system works doesn't mean it's true. It took a Polish priest named Nicholas Copernicus and a prickly Italian named Galileo Galilei to finally break the glass ceiling of the Ptolemaic universe. Galileo, using a telescope that was arguably worse than a pair of cheap binoculars you'd find at a toy store today, saw mountains on the moon and moons orbiting Jupiter. He saw that the heavens weren't a perfect, unchanging realm of gods. They were a place. They had geography. They had physics. But even Galileo's revolutionary telescope was just a better version of the Ishango bone. It was still an attempt to use our eyes to make sense of the clock. The real invention of modern astronomy didn't happen when we looked at the stars, but when we started looking at the light itself. In the mid-1800s, scientists like Joseph von Fraunhofer noticed dark lines in the spectrum of the sun. They realized that these lines were the fingerprints of chemical elements like hydrogen and helium. Suddenly, we didn't just know where a star was, we knew what it was made of. We realized that the same laws of chemistry that happen in a lab in Berlin or London are happening in the heart of a star billions of miles away. This was the moment the heavens died and the universe was born. It was the realization that there is no up there and down here. There is only everywhere, and the same rules apply to all of it. We are not spectators watching a show, we are part of the machinery. You might find it comforting to think that we've finally mastered the sky, that with our satellites and our deep space arrays, we have finished the work the Ishango bone started. But the truth is much more unsettling than that. The more we look, the more we realize that the clock we've been studying is actually a graveyard. When you look at the stars tonight, you aren't seeing things as they are. You are seeing things as they were. The light from the nearest star system, Alpha Centauri, takes 4 years to reach you. The light from the Andromeda Galaxy takes 2.5 million years. You are looking at ghosts. We spent 30,000 years trying to invent a way to tell time by the sky, only to realize that the sky is a medium that refuses to show us the present moment. We are trapped in a delay, watching a cosmic replay of events that ended before our species even existed. We invented astronomy to know when the seasons would change, but all we've really done is build a bigger and better way to see how much we've already missed. If you think about your daily life, you are still an ancient astronomer. Every time you check the weather, every time you plan a trip based on the time of year, every time you feel that slight shift in the air that tells you autumn is coming, you are using the biological hardware that was forged in the Paleolithic. Your brain is a pattern recognition machine that was designed to read the sky. We haven't actually changed that much. We've just swapped the baboon bone for a silicon chip and the stone circle for a space telescope. But the motivation remains the same: a deep-seated, primal fear of the unknown and a desperate need to find a pattern in the chaos. We want to believe that if we can just map the stars precisely enough, if we can just calculate the next eclipse or the next asteroid trajectory, we will finally be safe. We want to believe the universe is a clock we can learn to wind. But as we zoom out, the scale of our invention becomes almost funny. We live on a planet that is 4.5 billion years old, in a universe that is 13.8 billion years old. Our entire history of astronomy, from the first scratch on a bone to the James Webb Space Telescope, covers about 0.0002% of that time. We are like a person who has watched exactly one frame of a 3-hour movie and thinks they've figured out the plot. We have spent 50,000 years trying to read the sky, and we've only just realized that the book is written in a language we are still learning to speak. We are a very young species, standing on a very small rock, staring at a very large clock, trying to figure out why the hands are moving. If you've ever looked up at the night sky and felt a sudden, cold sense of insignificance, don't worry. That's just your brain doing its job. That feeling is the exact same one that prompted that person in the Congo 30,000 years ago to pick up a bone and start scratching. It is the realization that the world is bigger than you, older than you, and completely indifferent to you. Astronomy is the way we deal with that indifference. It's how we make the universe feel like a neighbor instead of a stranger. We name the stars, we group them into stories, and we track their movements because it makes the dark feel a little less empty. It's a beautiful, desperate, multi-generational project to turn the infinite into something we can understand. So, how did we invent astronomy? We didn't. The sky invented us. The cycles of the sun and moon dictated our biology, our sleep patterns, and our survival instincts long before we were even human. We didn't invent the study of the stars any more than a fish invents the study of water. We just eventually became conscious enough to notice the medium we were swimming in. We started as animals who were afraid of the dark, and we turned ourselves into architects of time. We took the terrifying randomness of the night and turned it into a grid, a map, and a calendar. We did it because we had to, and we keep doing it because we can't stop. The drive to know what comes next is the most human thing about us. Before we finish this journey, I want to ask you something. When you look at the moon tonight, or the next time you see a bright planet like Venus or Mars hanging in the twilight, I want you to think about that baboon bone. Think about the billions of humans who have looked at that exact same light and used it to decide when to move, when to hunt, or when to prey. We are all part of the same continuous line of sight. We are the latest version of an ancient eye set, still staring at the same screen, still trying to find our place in the pattern. If you enjoy digging into these kinds of rabbit holes with me, consider subscribing. We're going to keep pulling on these threads to see where they lead, because the more we know about where we came from, the less lost we feel in the present. It's a big universe out there, and it helps to have a map. We like to think that we've mastered the heavens, that we've pulled the stars down to Earth and turned them into math. We've built satellites that can see the beginning of time and telescopes that can photograph the shadow of a black hole. We've convinced ourselves that the sky is a solved puzzle, a clockwork machine whose gears we finally understand. We feel safe in our cities of light, where the glow of the street lamps hides the true depth of the void. But the invention of astronomy wasn't just about finding our way home or knowing when to plant seeds. It was the first time we looked at the infinite and tried to give it a name. We spent 50,000 years trying to read the sky, only to realize the sky has been reading our expiration date all along. The stars aren't looking at us, they are just waiting for the lights to go out.